Thank you. And I would like to welcome, as the Deputy Chairman of CII Northern Region, all the distinguished panelists, Mr. Minocha, Mr. V. Suresh, Mr. Vikas Malhotra, Mr. Suhas Dikshit, Mr. Ravi Jankar, and Mr. Mayor Garg. Thank you for your presence.
Mayor Garg, Head Infrastructure Service of the Rudrabhishek Enterprise Limited. And they're trying to talk in terms of using the refuse-derived fuel or biomass pellets for power generation. So could I ask Garg sir to kindly make his interesting presentation, how to use all the waste material as an important fuel, RDF component. Sir, please go ahead. Sir.
Yeah.
But try to make it in 7 minutes, not more. Sir.
Yeah.
We'll have some time.
Yeah, good afternoon to all distinguished panelists and Suresh sir. Yeah, here I share my screen. Yeah, I hope it is visible to everyone.
Not so far. It'll come, I'm sure, once you open. Ab tak aaya nahi hai. Yeah, it's coming now, opening now. Yeah, now it's come, sir.
Yeah, sir. Yeah,
very visible, very visible.
Yeah, I am Mayor Kumar Garg. I am Head Infrastructure Services. Joined REPL about a month back. Yeah, and why this topic of use of biomass pellets for electricity generation? I am thankful to Professor S.K. Tyagi of Department of Science and Energy Studies of IIT Delhi, who initiated me into this. And this is how the interest has developed.
Yeah. Yes, sir.
So I'm going to cover the sources. I think I'll straight away start. Yeah.
Yeah, you should better go ahead.
Yeah, we all know that the sources of biomass are forestry crops. We get it from the agriculture residue available from the field after harvesting is done, maybe from the sewage treatment plants, the sludge, the dried sludge, from municipal solid waste, from animal residues, and also from various industries. And these are some of the agriculture residue that we come across, which are generally used for making biomass pellets, wood, chips, sawdust, soft cuts. And yeah, you can see all this on the screen. Yeah. Now, the current availability of biomass in India, it's around 500 million metric ton. And as per the MNRE studies, it is around 120 to 150 million metric ton per annum, which includes agricultural and forestry residues also, which is equivalent to generation of around 18,000 megawatt of power. And why this is important? Like we all know that biomass is generated from the plants, from leaves or roots. And when they are alive, they are absorbing carbon dioxide because of the photosynthesis reaction. And when it is converted into biomass pellet, and when we burn it, the carbon dioxide goes back to the atmosphere. So in a way, it's a carbon neutral fuel. And even after considering the energy use, which is used in transportation, collection, processing, and making of the biomass pellet, it is significantly lower than the coal firing, so which makes it a greener alternative. This is how we make biomass pellet. That is, first of all, the biomass raw material is collected, brought to the pellet making mill. Chipping is done. Chipping, drying, pelleting, mixing and grinding and cooling and storage. I'll explain in the further slides. This is basically you are bringing the agriculture residue from the fields to the pellet making mill. Then you chip it, you make it in smaller sizes. Then if the straw is there, then with the particular shredder, you still make it smaller. Then chips, they are dried also. You don't want that the moisture content should be more than 10 to 12%. More moisture means you will have problem in pellet making. Ultimately, what you are going to do is you want to churn everything down to the smallest particle and then force it through a die so that you get the pellets. Pellets are generally of the size of 20 to 35 mm in diameter and same length. So this is what you're trying to achieve, which can happen only when the moisture content is less than 10 to 12%. So what you see here, yeah, at the bottom of the screen, these are the pellets. And torrefaction, why we do torrefaction? Torrefaction is nothing but you slowly heat this biomass pellets to 300 degrees Celsius to improve their energy content and also the finish. So what you get in return is only a very solid uniform product, which has got 70% of the total weight, and the energy content also comes down, but it is very low in moisture content. And these are generally preferred by NTPC. And lately, I'll come to that later on also. NTPC has started co-firing of the coal along with the biomass pellets, to the extent of 5 to 7%, so that these biomass pellets have a particular quality, that is percentage fines, raw material used, what is the moisture content, and also the gross calorific value. So both torrefied and non-torrefied biomass pellets can also be used. And all over the country, around 13 NTPC plants have been retrofitted to make use of the biomass pellets. This is how the biomass pellets look after torrefication. You see it become black after heating it for up to the 300 degrees Celsius. And the various methods of cogeneration of the sugar cane, cogeneration of the electricity in the sugar cane or palm oil industries or in the pulp and paper industry. And this biomass pellet can also be heated, converted into steam, and then used for running steam turbines for generation of the electricity. So what we are doing is, if you basically burn it to convert it into steam, then you are running a steam turbine which has got a very small efficiency of 20 to 30%. But if you use thermal gasification, that is, you use turbine combined cycle power plant or in fuel cells, you may increase the overall efficiency up to 40 to 50%, and which we call biogas integrated gasification combined cycle. Please. BIGCC. This slide gives you the idea how the world is using biomass for generation of electricity. On top, we can see it is a European nation, and Asia is somewhere down the line here at number 3. Up to 2016, we were generating around 350 terawatt hour per year. That is 10 to power 12 watt hour per year. Now, the capital cost of power plants using biomass. Basically, I've used the data taken from CSC, Center for Science and Environment. The cost of power plant using sugar bagasse or other crops is around 5.6 crores to 6.5 crores per megawatt. And for cogeneration plant, it comes down to rupees 5 crores per megawatt. And the cost of electricity using biomass costs you around 7.35 to 8.91 per unit. For bagasse, sugarcane bagasse, it comes down to 5.79 to 7.19.
Okay.
And if you compare this with the cost of the solid fuel, so it almost matches. And the power plants which are using this biomass pellets to be co-fired along with the coal, they specify the base material to be used, what should be the shape and size, percentage fines, and the gross calorific value, and the moisture content for the torrefied and the non-torrefied biomass pellets. NTPC gives a very good rate, around 24 to 25 rupees per kg, which is more than production cost of the biomass pellet.
But sir, we should close your presentation.
Yeah,
maybe
sure.
In a minute. Yeah.
Yeah, sure. And
because we already reached the outer end of the time. Slowly. Yeah, go ahead, sir. Go ahead. Sure. Please go ahead.
Yeah, we can use during making of the biomass pellet, we can use additives like lignin, starch, and animal dung. This is only to improve the surface quality. As of now, around 5 to 7% of the biomass pellet is used for co-firing in the thermal power plants. All India level, we see the thermal power plants which are available in India, around 40 million metric ton of biomass pellets can be used. So there is a
great potential to use.
Yeah, there is a tremendous scope to use by agro-based
Yes.
residue resource to our national advantage. And MNRE also promotes the co-generation of the biomass-based schemes in the sugar mills to the extent of rupees 25 lakhs per megawatt of the surplus energy that they produce. And they also give 10 years of the tax holidays, besides giving you rebate on the excise and the custom duty. And the state SERC also provides preferential tariffs for plants up to 10 megawatt. One megawatt, yeah. Now coming to this, yeah. Now we are
well ahead of
national
time.
Commitment.
Very close.
Yeah, sorry. We have a national commitment also to fulfill our this promise that we have made in COP26 through our Prime Minister, that we will bring down our energy requirement by 50% through renewable energy sources by 2030.
Yeah, very right. 450 gigawatt of energy, correct. This will all include, in addition to solar, other renewable. Okay.
Yeah, so I think this is a step in the right direction. If the biomass pellets can be used to the maximum possible extent in energy production and fuel for meeting our fuel requirement, and also it is a big boon to the citizens of Delhi and other places where you get air pollution during winter because of parali.
Yeah, very right.
This is what it is. Yeah, it is because of the interest in biomass pellet making that I have been.
Yes, sir.
Get this. Thank you.
I think it's a wonderful initiative. It was very interesting to see your new initiatives for the pellet, and I'm very happy the type of figures that you indicated. You can have 1 billion ton of the carbon footprint reduction. Your last line was that, and I'm very happy to note about that. And in terms of what is the calorific value that the new pellets can bring, this RDF can bring, as against your conventional coal or other energy-based one? Because you said you're mixing that cement plants, various people are mixing part of it with the other source of energy along with the, which is fossil fuel or whatever, along with your material on that. So first cost is on the on that area. If you can tell on the value, on the fuel value, calorific value per ton.
Sir, you'll be surprised to know it gives you a very good gross calorific value of around 5,000 kilocalories per kg.
5,000 kilocalories per kg. Okay,
yeah,
got it.
And what NTPC specifies is they accept up to 2,800 kilocalories per kg for non-tarified and 3,400 kilocalories per kg for tarified.
So very good. So it goes beyond 2,800 and 3,400. You're doing 5,000. Am I right?
Mm-hmm. Pretty good. The only problem is that the storage is a problem because it should be that wet. But you store that as must. And secondly, you need to have a consistent supply of the raw material because if you get a big order, NTPC or you have to supply somewhere, he will require this material to be supplied every day.
Can't you tie up with municipal corporations to give all the way so that you can convert that to refuse-derived fuel?
Sir, for RDF from MSW is also possible, but segregation has to be done.
Okay.
If you get segregated MSW, fine, you can do it.
Yeah, very, very interesting. And I did not open out in my opening remarks, but I am happy that with the presentation which has come over there, we are finally ending to net zero energy, net zero waste, net zero water, and net zero carbon at the end of the day. And I'm happy that all of you related that to the net zero carbon. And in your own segment also, you made the presentation towards the end of how much, if we are about 3 billion tons of carbon reduction. So carbon reduction can be 1 billion ton by 2030. That's a good indication from your side. I'm very happy.